Hello everybody, Dr. P here. Today we're going to do Math 20-2 Proportional Reasoning, Topic 3, Example 1 on page 29. So in this example, Maggie scanned an 8x10 photograph of a hummingbird to her computer so that she could change the size. If the photograph is enlarged by a linear scale factor of 4, determine the area of the enlarged photograph. So we're going to be doing this in two different ways. In method 1, we're going to first enlarge those original dimensions and then calculate the area of the enlarged photograph once we have those enlarged dimensions. In method 2, we're going to start by calculating the area of the original picture, and then we're going to use the area scale factor to determine the area of the enlarged photograph. Okay, so in the first method here, we're going to start by determining the dimensions of the enlargement. Determine dimensions of enlargement. Okay, so let's start with the width. So we have we're going to call it the width old, which is the original width, and that's 8 inches. Okay, so we can just take this, we can plug it into the linear scale factor equation. So this linear scale factor here is 4, our LSF equals 4, and the just as a quick refresher, the linear scale factor equation, the linear scale factor equals to the dimensions of, or the length of the new object, so in this case there will be the enlargement, over the dimension or length of the old object, or in this case it will be the original photograph. Okay, so we're just going to plug in our linear scale factor. We're looking for the new dimension, so we're just going to call it width, or W new, divided by the old width, which is 8. We multiply both sides by 8, and our new width is going to be 4 times 8, which is 32 inches. Okay, we do the same thing for the height, or length. We can call it length, I guess. Length of the old one. The length is 10 inches. Plug it into the equation or formula. So the length of the new one divided by the length of the original, or the old one, which is 10. So we multiply both sides by 10, and our new length is going to be 4 times 10, which is 40 inches. Okay, so that's step 1. Step 2 is going to be determining the area of the enlarged image. So determine the area of the enlargement. And because it's a rectangular photograph, it's just going to be, we can call it the area of the new one. It's just going to be the new width times the new length, which in this case is going to be 32 times 40, which is going to give us an area of 1,280, don't forget the units, square inches. All right, so that's method one, using the linear scale factor to obtain the area of the enlargement. Method two, now we're going to be using the area scale factor. So step number one in method two is going to be to determine the area of the original. So determine the area Okay, so determine the area of the original photograph. So we're going to call that area old, and it's simply going to be 8 times 10, which is 80 square inches. Okay. Step number two is going to be to determine the area of the enlargement by using the area scale factor. So it's going to be determine the area of the enlargement using the area scale factor, ASF. Okay, now the formula for the area scale factor looks exactly the same as the formula for the linear scale factor. So the area scale factor equals the area of the new object. So in the numerator, we're going to have area of new, and in the denominator, we're going to have area of the original or the old. Okay, so instead of putting in a dimension here, such as we did in the linear scale factor, the length of the new divided by the length of the old, we get the linear scale factor. For the area scale factor, we put in the area of the new object divided by the area of the old object. Okay, so let's do this. We know, well, we don't actually know the area scale factor, but if we take a look here, we have the area scale factor equation. This equation here that I just highlighted is just a different version of this one. What we've done over here is that we have, on the left hand side, we have the area of the new object. So essentially on the left hand side we have what's in the numerator here. And all we've done here is we have just multiplied both sides by the area of the old object and broken out or solved it for area of the new object. Okay, so these two equations are exactly the same. They're just being, this here is just a rearrangement of this one. Okay, the other difference here is that instead of ASF, the area scale factor, here we have K squared. It's just a different notation. It means exactly the same. Sometimes we refer to the linear scale factor as just K, and that's fine. It's just a notational thing. And what this here shows us is the relationship between the area scale factor and the linear scale factor. And the relationship is simply that the area scale factor equals the linear scale factor squared. Okay, or if you want to use this K notation, well, if the linear scale factor is K, then the area scale factor is going to be K squared. That's all this says. Okay, so what we're going to do here is I'm actually going to be using this expression, this version of the formula here, and then we'll have to rearrange it. It's a good exercise in the rearranging equations. So if the linear scale factor was 4, that means that the area scale factor is going to be 4 squared. Okay, so that means that the area scale factor is 16. So now we can plug it in. So the area scale factor is 16, and that equals to area of the new or the enlarged photograph. We don't know what that is. And then in the denominator, it's going to be area of the old one. Well, we know what the area of the old one is. It's 80 square inches. Multiply both sides by 80. And we're going to get the area of the new object equaling 16 times 80, which is 1,280 square inches. And obviously our answer here, the 1,280 square inches that we just got here using method 2, needs to be the same area that we got up here using the what they call method 1. Okay, so these are just 2 different methods we can use. There is a question B here as well. Suppose Maggie decided to decrease the size of the original photograph by a linear scale factor of 1/2. Okay, what is the area of the reduced image? Okay, so what we can do here is we have a different linear scale factor. Our linear scale factor here is 1/2. Okay, so we can determine the area scale factor as being 1/2 squared. Okay, this exponent here, this is a power of a quotient. This exponent here is applied to both numerator and denominator, so we're going to get 1 squared over 2 squared, which is the same thing as 1 over 4. So our area scale factor that corresponds to the following linear scale factor is 1/4. Okay, so now we can calculate the area of the reduced image in this case. So the area scale factor is 1/4. Okay, the area of the new image divided by the area of the original. Okay, so in this case here, this area of the new image represents the area of the reduced image. Okay, and this is of course the original. We multiply both sides by 80, and we're going to get an area for the new image of 1/4 times 80, which just really means 80 divided by 4, which is 20 square inches. Okay, there is a part C here as well. Determine the area scale factor if the linear scale factor is 1/2. Well, we did this right here, so we don't have to do that question. We already answered it. And that's it for today. If you have any questions, please ask them through the Google Classroom, and I see you in the next video. Bye.